Hello everyone. So today we are going to understand the low-level design of the pubsub system. What is pubsub system? The full form of pubsub is publish, subscribe. So it is a messaging pattern where publishers send message to topics without knowing who will receive them, and subscribers receive messages by subscribing to those topics. The popular example of this system are Kafka, Redis pubsub, and Google Cloud pubsub. So let's see the visual representation of how this system would look like. So as we said that there could be multiple publishers in the system and there could be multiple subscribers in the system. The topics are nothing but you can imagine that topic is something which holds the data or the message which subscribers have to read it basically. So basically, how the system works is there could be multiple topics, okay, and each topic has a dedicated functionality. Let's say this topic is holding all the alerts or the messages related to email. Let's say topic two is holding all the messages and the alerts related to news feeds, and there could be other some information which is held in the topic three. Now, publisher's responsibility is to put the messages into this topic. So, publishers will publish the messages inside the topic. Now, this published message should be known to the subscribers, right? So, subscribers subscribe to the respective topics from where they have to read the messages, like respective messages. Let's say a subscriber one wants to read from the topic one, so it will subscribe to topic one. Similarly, let's say subscriber two also wants to read from topic one, so it will subscribe to topic one. So multiple subscribers can subscribe to a single topic, right? And a single like in single topic could be subscribed by multiple subscribers. Make sense? So this is how the system looks like. So here publishers are not at all knowing like who is subscribing to that topic and who is reading from it. Its duty is to just send the messages to that topic. Subscribers who have subscribed to that topic will receive those messages and process it at their end. So this is how the system looks like. Now let's understand the functional and the non-functional requirements. So as a system, what should the functionality it should exhibit is covered under the functional requirements, and all those like non-functional requirements usually focuses on how the system should be like it should be scalable, it should be modular, how it should extend in future. So all those are covered in non-functional requirements. So first, let's see what are functional requirements of our system, which is the core requirement which our system should exhibit. So first thing is like we are allowing multiple publishers to publish message to topic. Also, we will allow multiple subscribers to subscribe to one or more topics, as I explained previously. And messages should be delivered to all the active subscribers in the order they are received. So we are making sure that we are not like subscribers are not getting messages out of order. So we are pertaining the order here and ensuring that we want to ensure non-blocking asynchronous message delivery. What does this mean? So basically, if you see in the system, there could be a chance that the publisher end who are publishing the or sending the message to the topics are producing messages at a very high intensity. When I say very high intensity is like number of messages generated per second is too high. So it's not necessary that the rate at which they are sending the messages to the topic, the same rate would be at the consumer, like subscribers end to consume those. They might not be able to consume those messages at that same rate. So what we want to achieve in the system is let whatever the rate at which the publisher is sending message to the topic, it will take in all the messages which are coming from the publisher, and when it's time for consuming those messages from the topics, subscribers will consume at their own rate. So we are introducing asynchronous behavior in our system. We are not making sure that once a publisher is publishing the message, as soon as it is published it is consumed by the subscriber. So that is something which is known as the synchronous behavior. We are not concerned with that behavior in the system. And if you even look at how the Kafka is working, so it's basically the use case of Kafka and Redis pubsub and the Google pubsub queues. Basically, this queues main motive is to have the asynchronous behavior into the system, and also we will make sure that we will have a system which supports creation and management of topics. So these are the core functional requirements which our system would be exhibiting. Now let's see at the non-functional requirements. So non-functional requirements could be like, want to make sure that we follow object-oriented principles with clear separation of responsibility. So we want to make sure that our code is modular. Even we want to make sure that, let's say if we have in future multiple concurrent publisher and subscribers into our system should be able to scale it up with that concurrent publishers publishing the messages to our system, and the consumers, which are subscribers, which are reading those messages from their respective topics. So, and the third one is like, we want to make our system more extensible, meaning flexible enough to support future enhancements such as message persistence and retries. So now let's understand the core entities which our system would have. So let's say before moving to the core entities, let's say if this type of question comes in the interview, the first thing is like, generally the interviewer would just say that what is, like, it will say that design a pub-sub system or publisher subscriber system. This is a very famous question which is asked in the LLD. Most of the time it's an expectation for an LLD rounds. So here, basically, let's say if you're not aware about it, you can ask the interviewer what is the pub-sub mechanism or how it is. Once you have the idea, you can list down the functional requirements and discuss with your interviewer so that you both are on the same page before you deep dive into the design of the same. And after discussing of the functional requirements, usually for determining the core entities of the system, we try to make sure that whatever we have described in the functional requirements, we try to pick up our entities from there itself. Now we will see when we will discuss the core entities. Like, we try to make sure that we define the entities based on the requirements, functional requirements which we have defined for our system, right? So we will try to identify that. Once we have that identified, we try to have the class diagram. We'll see all this in our explanation as well, but I'm just giving you high level overview, like whenever this question comes to our interview, how you should basically approach it. So once you have the entities defined, the next step is like defining the relationship between those. Like, how will those entities interact with each other? It's basically known as a stitching of your entities. Once you have that, you will get the complete diagram, class UML diagram for your system. Once you have that, and once you and your interviewer are like on the same page of like, yes, we are satisfying all the requirements and this is what is the expectation from this question or from the candidate, you go ahead with writing it in one of the object oriented supported language. It could be C++, Python, Java, whatever. So this is how this rounds basically look like. And here also sometimes in some of the interviews with interviewers and interviews which I have faced, is expectation would be right to have a code which is runnable. Like, it's not just to define the classes and the entities and the relationship. It's not just done over there. Sometimes the expectations are that you provide a code which is runnable. They'll test on the multiple test cases, use cases, and they'll see that it is producing the expected results. So it depends. So this all things would be clarified at the start of the round itself. If it is not, you should explicitly ask like, what is the expectation of this round, so that you can manage your time very well. So now let's see the core entities of the system. As you mentioned here in the first functional requirements, that we want multiple publishers to publish message to a topic. So first thing is, we would require some entity which is a topic, which would be managing the list of subscribers. So topics would be having the list of subscribers, and then they would distribute messages to those subscribers asynchronously. Now, as we said that messages would be distributed, right? Something is getting pushed inside the topic. Now what is that? That it is a message. So next entity which comes to my mind is message, and hence I'll have message, which will be a single unit of data published to the topic, and it contains the message contains and the timestamp. Here we have kept it very simple, that it will have just content and the timestamp. Now, as I mentioned that in the second requirement is functional requirement, we have multiple subscribers to subscribe to one or more topics, right? So we would need subscribers also into our system, as each topic will be holding the list of subscribers. right? So every topic is holding a list of subscriber. So we would need another entity which is subscriber, whose responsibility would be that entity that reads from one or more topics. Definitely it would be reading from one or more topics, meaning like it is subscribed to one or more topics. And it can also unsubscribe at the runtime. Let's say that subscriber felt that it does not want to consume the data which is getting sent into this XYZ topic, it can also unsubscribe at runtime. Now, to have all this, like we have satisfied one, first function requirement, second, like defining the entities for the same, the third one as well, and the fourth one, like asynchronously, we will be delivering message to the subscribers which are in the system, and the management and creation of the topics as well. Like we are going with the entity topic, so its management and creation would also be taken care at. So now we will have some central coordinator for our entire system. So here we make sure that we expose the APIs to the client. Like those APIs would be, like what all APIs would be published to the client would come under this entity, which is the pubsub service. It acts as a central coordinator, providing the APIs to create a topic, manage subscription. Let's say we want to subscribe, unsubscribe, add topics, like whatever we want to create topics, we want to add subscriber to that topic, we want to unsubscribe subscriber from that topic, all those. And even the whenever the messages are getting like routed to the respective uh, m- published messages would be getting routed to the respective appropriate topic as well, so that all things would be taken care by this pubsub service, right? So this will be central coordinator into our system. And apart from that, we won't be exposing other like whatever we have in a system to the clients. We usually give one interface, API interface to the client, which would be an orchestrator kind of thing, which will be managing all of these requirements which our system should support. Now, let's understand the class diagram and how each of the entities are related. So, now let's move into the basic entity, which is the message. So, it will have the message content, as I mentioned, and the timestamp, and we will have these methods, so it's nothing but the getters, so getting the message content and the timestamp, and this would be the constructor of the class. Now, as we discussed that we would have the subscribers, right, into our system. We will have multiple subscribers, and those subscribers can subscribe to multiple topics. So here we have defined an interface subscriber. So it will have basically the ID and the method, like two methods basically, the get ID and on message publish. Whatever the message is getting published, this two functionality would be implemented by whatever the concrete implementation of this interface would be. They would be giving the implementation of this method. So get ID is nothing but getting the ID, and on message publish is nothing but whatever the message is getting published or sent to the topic, that would be read, is what the functionality of on message publish would be. And we would have, like why did we go ahead with creating this subscriber as an interface, is like we could have multiple subscribers in future also coming to our system. So let's say in future we have some other new subscriber getting into our system, so it just has to give the concrete implementation of this interface, the way this SMS subscriber and email subscriber are defined right now. So these two are implementing this interface. So it will give the logic for get ID and on message publish. We'll see this detailed implementation in the code walkthrough. But this is the interface subscriber, and this is the concrete implementation of that interface. Now let's understand the other important entity of our system, which is topic. So topic would be basically holding the list of subscribers, because topic's responsibility would be to add or remove subscribers dynamically at the runtime, and even whenever the message gets published, to notify all its respective subscriber that message has been published. So for this purpose, we will have the topic, and also we are making sure that the message delivery to the subscribers are asynchronously, right? That is what the expectation of our system is. So we'll have the topic name, we'll have the list of subscribers which are getting subscribed to this topic, and we'll have an executor service. So this is basically uh, implementation in Java, the executor service class, which allows us to have an asynchronous behavior into our system while like whenever we'll be sending the messages to the subscribers, we will send them asynchronously to exhibit that behavior. Specifically in Java, we have this class executor service. So I'm holding the instance of this executor service class here. And we'll have the constructor, which will have like will pass in the topic name and the executor service. So every topic will asynchronously pass the message to its respective subscriber, and hence we are holding the instance of this executor service at the topic level, right? We will have addition of the subscriber method. So this method's responsibility would be to add the subscriber to this list of subscriber. Remove subscriber would remove the subscriber from this list, and notify subscriber will make sure that all of the subscribers which are held by the topic at that particular point of time would be notified with the message, right? So this is the entity topic. Now let's see the pubsub service uh, central coordinator of our system. So here also it will be holding the topics registry, because management and creation of topic is maintained by this service. So this map is nothing but we will have the name of the topic and will hold the instance of that topic, and we will make sure that we are following singleton design pattern here while getting the instance of this service class. So hence we have this, we are making the constructor of this class as private. That is how the singleton pattern is implemented. And we will make sure that get instance would give me return me the instance of this pub sub service whenever I'll call the get instance method. We'll see that in the code, nothing to get overwhelmed here. And as I mentioned, that creation of the topic would be taken care by the service. So we'll have the method create topic and we'll pass in the topic name here. Subscribing, like when also the subscribing, unsubscribing, like we also had the function requirement where we had mentioned that management of subscription is also taken care by pubsub service. So whenever we'll this is something, this all services would be exposed to the client. So basically dot subscribe would be called to that topic. So to that topic, this subscriber should get subscribed, right? And unsubscribe would be like from this topic, this subscriber should get removed off from this subscribers list. And publish messages would be like whenever the message is getting published by the publishers, which is the publishers of our system, uh, we would notify this topic that like whatever the subscribers of this topic are would get notified that message has been published. And we are this void shutdown is nothing but we are making sure that we are simulating this in the multi-threaded environment. So we want to make sure that at the end we close our thread pool and we shut down our system. uh, we don't abruptly stop it, we gracefully shut down our system. Now, this is the main method which will be interacting with the service class basically. So as I mentioned previously as well in the functional requirement that whatever the APIs we will be having in our system exposed to the client would be in this pubsub service class. So main would be interacting from here with this class itself. Now let's see the relationship between all of these entities in detail. So here if you see that message is nothing but the basic entity. So this basically topic would be this like it would be holding right this message entity. So here whenever it will be publishing this messages, so it publishes the messages. Now topics would be holding the list of subscriber. So here we make sure that whatever this list of subscribers getting hold here, so it defines a composition relationship here that we would need a list of subscribers here. So topics are holding its subscribers, so hence we have a composition relationship here this is nothing but implementation. So implements. So this is the interface, and these are the concrete implementation. So this is nothing but an implements relationship. Now, pub/sub service holds the list of topics. So here also we are having the composition relationship. So because here it is holding the topic registry, which holds the topics present in our system. So here we have, as I mentioned, that we are following singleton design pattern, one of the design pattern to get the instance. One more design pattern here we are following is strategy design pattern. If you see here, we are making sure that we are uh, not having, like, we are making sure that we define an interface subscriber, and let's say whatever the future uh, logic of any new subscriber we want into our system could just go ahead and define its concrete implementation. So to understand this design pattern, I have created a detailed video about how the strategy design pattern works. I'll drop a link in the comments, in the description as well. So you can just go and check that out to have better understanding. And what else we are following here? So that is the two design pattern which I could see. Also, if you see here, we are also following the observer design pattern. So let's say here we are making sure that whenever the state of the subject changes, we notify all of its respective subscriber. So here the state of the subject could be like here whenever we have any of the messages getting into our topic. So that is the state of the subject getting changed. Its respective subscriber gets notified. Right? We are maintaining this list of subscribers here that gets notified. So we are also following the observer design pattern here. So again, to understand it in detail, I have created a detailed video, sorry, on my channel. I'll drop a link in the description to just go and check that out to have a better understanding. Now I'll keep this diagram of this UML class diagram on the left hand side, and we'll have the code on. Sorry, I will keep this diagram on the right hand side, and we'll have its code on the left hand side so that it's better to walk through and it becomes easier as well to connect. So now let's deep dive into the code implementation for the same. So now let's first go through this message class. So this is simple message content, timestamp, simple basic class. We are not having just, we are having the getters to get back the values. Now let's see to this subscriber interface, right, and its respective subscribers, which we have defined the concrete implementation. So as I mentioned that we'll define a interface subscriber. We'll have two of these methods, and get ID and on message publish. And we have the concrete implementation email subscriber, uh, which is getting subscribed into our system. And we'll have like here we are not giving any such processing step because this is just for understanding purpose. So I have just added the print ln statement here, like on message publish. We are saying that we have got this message basically, right? The subscriber read this message when it got published into the topic. Same goes for the SMS subscriber. So this is about the subscriber interface and its concrete implementation. Now let's see into the topic, how it looks like, the entity topic. So here we have the topic name. We have maintained the list of subscribers. The topic would be holding, and we have the executor service. As I mentioned that this is basically the implementation in Java, right? For the respective of the programming language, you need to see that how you can asynchronously perform the task. So if you read here, an executor that provides methods to manage termination and methods that can produce a future for tracking progress of one or more asynchronous task, right? So it is basically for produce performing the task asynchronously. So here we are making sure that topics, whenever they are sending the messages to its subscribers, it is done asynchronously. So whenever this is the constructor, when our topic gets created, we will have its name, and every topic will be having its respective executor, right? Because we are, you can imagine that there are because we have multiple topics in our system, so every topic will have its respective executor service, and which will make sure that asynchronous behavior of publishing the messages to the subscribers is taken care by it. So here the list of subscribers, we are making sure we are using copy on write array set. So this is to make it thread safe in multi-threaded environment, right? We have add subscriber, which will just add the subscribers to the list of subscribers. Remove would remove, and notify would make sure that for every subscriber which that topic is currently holding, it will try to submit. This is nothing but how the asynchronous way of um, sending the message, submitting the task would look like, not sending the message, but submitting the task. So here we call the executor service dot submit, and we call the subscriber respective subscribers on message publish method. So this would basically, let's say if it had both of the, like topic one or whatever the topic had both of the subscriber email and SMS subscribers. So let's say list is holding two subscribers right now. So it will respectively call each of its on publish method, right? So subscriber dot on publish would call this methods. So that is what we have implemented here. This will ensure that the message delivery to the subscriber is asynchronous, right? Now let's see the pubsub service class, our central coordinator, right? Okay. Okay. So if you see here, here we are having an instance of this class, right? And as I mentioned that we are trying to follow the singleton design pattern here. Why? Because we don't want whoever who is calling our services just don't go ahead and create multiple instances of this class. This might lead to the exhaustion of our heap memory, because whenever an instance gets created, it allocates the space inside our heap memory, because whenever a new keyword gets invoked, it allocates space inside our heap memory. So we don't want to run out of that, and hence we make sure that we just have a single instance into our complete system, right? So that is the reason we are following this pattern. So for that, we make sure that we have made our constructor as private. That is how this pattern works basically. And we'll have this method get instance. So its responsibility would be to return the instance of this pubsub service class, right? And you can say that we are maintaining the topic registry. So this is nothing but holding the topics the system is having right now. And it's a map. So it's a name of the topic and its instance is getting hold here. And okay, so we said that we would be managing the creation of the topic, the subscription of the managing the subscriptions, and even responsibility of this service class would be to publish the message. Like whenever the message is getting published inside the topic, to notify or to tell respective subscribers of the topic that message has came into. So all of these responsibilities would be fulfilled by this class. So let's see one by one. So creating the topic is nothing but we are trying to put in the map, like if we don't have this topic, then we go ahead and try to put it. Put if absent, make sure that if it is having, it doesn't. But if it does not have this topic, it will create the new topic, put it up. And we'll have the println statement that we have created this topic successfully, and for the logging purpose, just for the logging purpose. Now we what the subscribe will do is, like for this particular topic we want to subscribe subscriber, right? So we will pass in the parameter topic name and the subscriber. So first we'll go ahead and search in our topic registry that do we have this topic. Let's say if we do not have this topic, we'll throw an argument, a legal argument exception that topic is not found. And let's say if we did not fall into this logic, like we had this topic present to our system, we'll go ahead and add the subscriber. So when we'll call this topic dot add subscribers, it will basically call this method. So topic dot add subscriber method will be called, and it would add the subscriber to this list of subscriber the topic is holding, right? So that is how this add subscribe method would work. Similarly, unsubscribe, everywhere we are checking this, that whether if we are having this topic or not. So let's say if we have this topic, we'll go ahead and call remove subscriber. So it will call this method. and it will remove subscriber from this list of subscriber which topic is holding. And publish message would be called like whenever the publish message API is getting hit. So what we'll make sure is like for this particular topic, the message is getting pushed, right, by the publishers. So we'll pass in two parameters, topic name and the message here. Again, we'll check that whether we have this topic in our system or not. Let's say we have that, then we'll call the notify subscriber method of the topic. So what it will do is, and we'll pass in the message. So it will hit basically this method. So for every subscriber for this particular topic, it will go ahead and call that we have this message to that, like it will basically tell the subscriber that this message is getting added to our topic. Go ahead and consume. So subscriber dot on message publish will get called. So it will basically go ahead and call this on publish method for respective subscriber which are subscribed to that topic. I hope this makes sense. And shutting down is nothing but I made sure that this, I previously told that this is the multi-threaded environment we are simulating in. So here we are trying to stop this executor service pool gracefully. Now let's understand and simulate this via our main method. So here I'm not creating the instance because as we are following the singleton design pattern, we'll call get instance, which will return with instance of this publish pub service. Sorry, pubsub service. And we have different subscribers. Here we have one email subscriber and two SMS subscribers in our system. We will create two topics, which is email topic and SMS topic. So for creating the topic, it is responsibility of pub service class. Pub sub service class dot create topic will go ahead and call this method, and it will add the topic into our registry, which we are holding in memory, right? So that will create these two topics. Once we have created this topic successfully, we'll go ahead and subscribe the subscribers to that topic, right? We will subscribe the SMS subscribers to SMS topic and the email subscriber to the email topic. So this will call pubsub service.subscribe. So it will call basically this method, and with the topic name and the subscriber, it will subscribe that uh, respective subscriber to that topic. So when this line gets executed, it goes ahead and calls this class add subscriber, and it adds that subscriber to this list of subscriber for that particular topic, right? Now, after that subscription has taken place, we'll try to publish the message to the topic, right? So pubsub service dot publish message would be called with the parameter topic name and the message content, right? So here we are creating this message, that message published to the SMS topic and message published to the email topic. So it will basically call this method publish message of pubsub service class with the topic name and the message. So it will go ahead and call for this topic, whatever this topic is passed in, the notify subscribers method, which is basically this one. And for whatever the list of subscribers this topic is holding, it will go ahead and call this on message publish. So let's say it was holding email and SMS both. So it will call respective on message publish methods. Now and after that we have introduced a delay of 1 second, right? This will introduce me a delay of 1 second. And then we'll see the scenario of unsubscribing and republishing, right? Again, like we'll unsubscribe one of the subscriber from the topic and we'll try to publish the message again to see how it works. So basically, once we unsubscribe that subscriber from our topic, when we publish the message again, that subscriber should not be getting that message technically. So that is what we have done. We have unsubscribed. So it will call this unsubscribe method of subservice class. It will remove the subscriber from this topic's list of subscribers. Once it is unsubscribed, we'll publish the message again to respective topics and we'll see that whether or not the subscriber is getting the message or not. It should not, right? And then we have again introduced a delay of 1 second, and then we are successfully executing out from our system. We are shutting down our pubsub service class. Now let's run this into our terminal. So yeah, if you see, we created two topics successfully. Once a topic got created successfully, we started publishing the messages to the topic. So we had two SMS subscribers. We would make sure that both of that get the messages. So both of those got, and there was one email subscriber. So that messages also got to that subscriber. And then we unsubscribed the SMS subscriber, SMS SUB1 subscriber with that ID. So then again, if we publish, that subscriber would not get that message. So if you see here, SMS for SMS SUB2, and the message got received to them, and we got, and again to one of the email subscriber which was there in the system. So SMS sub 1 with that ID, that subscriber is not getting the message. And then where pubsub service got shut down completely. So yes, this was all about this system design, basically the low level design of the pubsub service or pubsub system. I hope you like the content. If you like the content, do like and subscribe to my channel, and I'll keep posting such interesting tech content onto this channel. Till then, bye bye, take care, and have a nice day.